This is done already.
Last level.
Acha, the various relations involving refractive index is not done. So, have you done these formulas for refractive index?
Yes.
How do we read this? What is written on the board? How do we read this? On the left hand side. We read it N21 or we say refractive index of second medium with respect to first medium. What do we say? Refractive index second medium with respect to first medium. So then there are some more formulas. Refractive index is also defined like this. V1 by V2. Have we written this formula? No. Okay. So refractive index is also defined by this formula, which is speed of light in the अरे AC pro कम करना सर
वो refractive index of U11 वो constant है ना.
Yes, it is a constant. This thing is constant for a given pair of medium. Pair of medium and given color of light. Color means wavelength. Of light. चालू करना थोड़ा टेम्परेचर कम है लेकिन 20 कूलिंग है ना उसका speed of light in second medium. So this is another definition of refractive index of a medium with respect to the incident medium. Now third is concept of absolute refractive index. Now what is absolute refractive index? So this is defined as N21 is equal to C by V. What is absolute refractive index? When the first medium is air or vacuum, then the refractive index of the second medium is just written as N2. The first medium is not specified. Okay? In this case, the first medium is not specified. So whenever we talk about absolute refractive index, it means refractive index of the refracting medium, the second medium. So all the table that is there in your volume and textbook, all the refractive indexes are with respect to air. When the substance is mentioned with the refractive index value, it means it is with respect to air. Got it? So note, absolute refractive index is the refractive index of the medium with respect to air or vacuum. With respect to air or vacuum. Okay?
So what's that C by V is equal to N2?
When first medium is air, then the speed in the first medium V1 becomes C. Speed of light in air. And V2 becomes its speed in the refracting medium in the second medium. This formula.
So that is equal to N2.
Yes, we don't specify the medium. First incident medium we don't specify. In case of absolute refractive index. You have to understand, if the first medium is not mentioned, that means the first medium is air or vacuum. Okay? Now, fourth formula. N21 is equal to V1 by V2. Right? So, you can multiply and divide by C. Okay, you can do this. Then you can rearrange them as V1 by, as C by V2. C by V2 into 1 upon C by V1. Can you do this? First we multiplied and divided by C. So this does not affect V1 by V2. Then we rearrange. So what does this give us? This gives us it is the expression of relative. Now this is called relative refractive index in terms of absolute refractive index. Relation between relative refractive index with absolute refractive index. So I'll give you an example. Suppose you have two substances as glass and water. Let us say glass and water. So this will be equal to refractive index of glass divided by refractive index of water. Yes, what's the crisis? I will read it for you. Anybody having difficulty understanding or looking at it? Just stand up and sit down. Yes. Okay. So, yeah, this is C upon V2. This is C by C, right? So this C by V2, that is together, and this V1 goes under C. A by B divided by C by D is equal to A by B into D by C. Simple. Okay? That's what we have done. So here A by B divided by C by D is equal to A by B into D by C. Okay? So this is the example. Suppose you have water in a fish tank. So that is, then what is the relative refractive index of glass with respect to water? It is the ratio of refractive index of glass to refractive index of water.
So we can also write speed of light in water upon speed of light in glass.
Yes, you can do that.
Both
are correct. Because this is nothing but that only. This will give you this only. Na? So C by V2 खत्म हो गया ना. V1 by V2 से तो हमने start ही किया. We started from that, what you are saying, and arrived here. Both are similar. Okay? So depending upon what is asked in the question. So you can ask me. NGW. Now this is an example where the second medium is glass, the first medium is water. Like a fish tank in which water is filled. Got it? Now it NG by NW. Which one? Yes.
I really did not understand what is like the C upon V and stuff. whatever you
So
like.
this is how we have defined what is absolute refractive index. Okay. First, this definition. Refractive index is also defined as ratio of speed in the first medium, which is incident medium, to the speed of light in the refracting medium, the second medium. Correct? This definition understood?
Yes.
Okay. So for a pair of medium, once we have found out this, then this can be experimentally verified. Okay. So this, having understood this, now we have defined what is absolute refractive index. Absolute refractive index is the ratio of speed of light in air versus speed of light in the medium. That means what is the pair of medium here? The pair of medium is air and the second
And
medium.
the medium. Yeah.
Now V1, for this case, V1 becomes C and velocity V2 in the medium we have taken as V. So whenever the first medium is air, okay, we call the refractive index as absolute refractive index for the second medium.
Sure.
Then we don't specify the first medium. Then generally we specify the second medium also, first medium also, right? Which is the incident medium. But when we don't specify the incident medium, that means it is the absolute refractive index of the second medium with respect to air. Okay. So having understood this, now
Yeah.
how do we relate? Now this is now called relative refractive index. Relative refractive index. Between these two medium, pair of medium. But when the first medium of the pair becomes air, then we don't mention it. Okay. So now we are deriving a relation between a relative refractive index with absolute refractive index. That's what we have done. So we have used here the previous definitions. You get it? So now we have V1 by V2 because always we may not get for relative refractive index. You know, we may have glass and water, so there is no air in this. Okay, so relative refractive index of glass with respect to water is given as ratio of absolute refractive index of glass with respect to absolute refractive index of water. And Ng is what? Where what is Ng? Ng is C by Vg. What is Nw? C by Vw. Got it? What
Yeah.
is absolute refractive index of glass is speed of light in air divided by speed of light in glass. That's what it is. Okay, so you can write this also, just in case you're having difficulty understanding. Is it clear? Clear to everyone?
Yes, sir.
Okay. Very useful for solving numericals. Okay. A lot of time, lot of confusion happens because this funda is not clear. What is absolute refractive index? What is relative refractive index? It should be clear now. Okay. More useful when the mediums are non-air. Then relative refractive index becomes very clear. Okay. But the given values of Ri of any substance is always absolute refractive index. Okay. तो यहाँ पे ये useful हो. So with this, we have completed all the relations of refractive index. There is one more thing. Fifth, N21 is also equal to 1 by N12. Okay. What does this mean? Refractive index of second medium with respect to first medium. It can be shown that it is equal to reciprocal of refractive index of first medium with respect to second medium. So how you can show this? Dekho, since N21 is equal to sin I by sin R, this is equal to 1 by sin R upon sin I. Correct?
Yes.
So what is this now? 1 by n 1 2. Okay. So why? How you can do this? Dekho.
So how sin r upon sin I will become what?
I'll tell you. Right. Let's say this is air, or this is first medium. This is my incident medium, and this is my refracting medium. Okay. So this is R. Correct. So if you apply at the point of incidence the Snell's law, what will you get? N21 is equal to sin I by sin R, right? Now, if I reverse the path of light, if I go from here to here, what it is? What it is? I just go from here to here. Let's say right now I came from A, O, B, right? But if I now go from here to here, let us say, obviously, if the light would have gone back, it would come out with angle I. So if I reverse the path of light, it will retrace the path, right? So then what it will be then? It will be N12, isn't it? At this point, isn't it? So that's what it is. Everyone got it?
Yes, yes.
When you go from B to O, right? When this becomes incident ray, then refracted has to be OA. But now what about the medium? Incident medium is now 2 and refracting medium is A. And when we write this, we always write the refracting medium first. So the mediums are interchanged now. First becomes second, second becomes first. That's how it is reciprocal. Got it? So with this, we have completed all the relations involving refractive indices. Okay. So now there is a in-text question in your book. Everybody has NCERT textbook?
Yes, sir.
So somebody read the question, the first one. Just before lenses, refraction of spherical lens. Yeah, read it.
Array of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? Why?
And why? Okay, I'll choose who will answer. Okay, everybody write the question.
Yes, sir.
Okay, you answer. You answer. You are raising hand.
I was asking you to read the question. I don't know.
Read again. You will know the answer. Read again. What's the page number?
150.
Page number is 150. So where is light ray traveling from? From air to water. Water is denser or rarer? So light is entering into a denser medium. So what should happen? It should bend. It will slow down, right? When it slows down, it will bend towards the north. We discussed it, right? So and why?
So because it is the
Slowing down.
because of it is from
more than the.
it is passing.
Yeah, it's more. See, it's more. That's why it is slowing down. So when it slows down, then only, because if it is going fast, it should either travel straight, or if it is speeding up, maybe go away. Okay.
So because the ray of light have to cover the least distance in a medium and if it move towards the normal it gets in the least distance.
Given the hypotenuse
Yes.
reduces. ठीक है उतना technical नहीं आना. Just talk in terms of either the speed increases or decreases. If the speed decreases, what you're saying is correct technically. Okay. So what he's saying is because it has to travel least distance
In a medium.
in a medium.
So moving
So without slowing down, how will it travel least distance?
because moving towards the normal, it will get the least distance in that medium.
You have to correct still the speed, right?
There is a distance in the it will decrease.
Without slowing down, how it will travel that way. So keep it to the definitions. Just say when it slows down, it bends towards normal. When it speeds up, it goes away from the normal.
I search it on Google.
Okay, Google is not classified. It's a medium of expression. Like you, like him, he will put something on Google. Anything on Google is not validated info. Has somebody validated it? I mean, today if I want to put up something on Google, will Google stop me? It depends on the site, whether it is classified like Wikipedia, they have a team. Okay, which again, the team could be biased or unbiased.
Wikipedia is open source.
Huh?
Wikipedia is open source.
Open source, but it has a technical committee, so you can't contribute just like that.
Yeah.
So as long as nobody has objected, the post will lie there. But if somebody objects, then the committee will remove it. So it's like audited platform. It's not open in the true sense, right? So open source does not mean, but it should be credible also, na?
But I have taken MS search it on AI.
Huh? Come on, yeah. AI is still artificial intelligence. They're still growing up. ठीक है देखो technically the same thing at various level at 10th level we don't need to discuss that you have to actually justify with the definitions first नहीं यार वो ठीक बोल रहा है लेकिन उसका definition यहाँ नहीं लगा you have to stick to the source okay तो वो
You can say that
अभी जो टीचर करेक्ट कर रहा है टीचर लोग कैसे करेक्ट करते हैं उनके पास एक रेफरेंस आंसर होता है तुम्हारा आंसर उससे मैच नहीं हुआ वो सीधे काट देगा समझ में आया so they are expecting the answer which matches the description given in the textbook the main source and this is the main source for you so don't get the right answer from any third party source answer should match this okay तो अभी हमने definition किसमें सीखा है refractive index का in terms of ratio of change of speed उसमें आंसर होना है is that correct
so yes, it is passing from optically nearer to denser.
optically rarer to denser वो भी हमने discuss किया ठीक है तो why में why all the discussion was because of why okay now next पढ़ो तुम
From air to glass having a factor index.
right you're laughing what's so hilarious 1.5 next
But in the speed of light in the glass, the speed of light in that case is leading to 10 raised to power 8 meter.
okay so which formula second formula correct you have to use this okay so what is given just solve it
1.5 and
everybody solve it for yourself tell me the answer question 2 n2 bar is equal to beta by b2 so what is given 1.5 is equal to 3 into 10 raised to 8 meter per second divided by where does it enter light enters from air to glass what is the speed of light in the glass so this will be vg second medium is glass right so vg is equal to 3 divided by 1.5 into 10 raised to 8 meter per second. So this is 30 by 15, 2. Okay, 30 by 15. Here is double of 1.5. Question 3. What's question 3?
find out the highest optical density and lowest optical density.
So in your book there is a table. So highest is diamond, lowest is air.
Yeah.
Okay.
The lowest is vacuum.
हाँ, पर उसमें हमारे टेबल में वैक्यूम दिया नहीं है. Vacuum should be 1. Vacuum is 1. Here is almost 1. Question 3. Highest optical density.
That time.
What is this? 2.54.
2.42.
2.42 or diamond. Lowest किसका है?
Air का 1.000.
For air. Okay. So this was a straightforward question. Fourth also you can answer from the table. You are given kerosene, turpentine and water. In which of these does the light travel fastest? Water.
The water.
So the one with least optical density, which is least refractive index. Okay, which is water. Okay, fourth answer is water. Why? Because its
As the least of the
Ri is least. Because refractive index gives the comparative velocity. Okay.
So if the density is more than the reflective index will be more.
Okay, what is the velocity in the second medium? V1 divided by Ri. Isn't it? ये होता है ना? तो जिसका रिफ्रैक्टिव इंडेक्स लीस्ट होगा उस मीडियम में स्पीड विल बी मैक्सिमम.
So
What is-
water has the minimum speed. The light will have.
वाटर हैज लीस्ट रिफ्रैक्टिव इंडेक्स. बेंडिंग कम करेगा ना तो स्पीड ज्यादा होगी. बेंडिंग ज्यादा होगा तो स्पीड कम होगा. नहीं समझा? ये डिनोमिनेटर ग्रेट है, क्या है? वाटर का कम है. लो डिनोमिनेटर मींस हाई V2. नहीं समझा? इनवर्सली प्रोपोर्शनल. जिस मीडियम का रिफ्रैक्टिव इंडेक्स ज्यादा होगा उसमें स्पीड कम होगी. जिसका रिफ्रैक्टिव इंडेक्स कम होगा उसमें स्पीड ज्यादा होगी. Now here we are comparing mediums, refracting mediums. केरोसिन एक रिफ्रैक्टिंग मीडियम है. वाटर अलग है, टर्पेंटाइन अलग है. इन तीनों में से वाटर का रिफ्रैक्टिव इंडेक्स लीस्ट है. ठीक है, तो उसमें स्पीड एज कंपेयर टू केरोसिन एंड
Sir,
टर्पेंटाइन
water का density उससे ज्यादा है.
नहीं है ना.
अगर कम है
इसीलिए तो उसका रिफ्रैक्टिव इंडेक्स कम है. लगता है देखो मास डेंसिटी ज्यादा है वाटर का. अगर केरोसिन तुम वाटर के ऊपर डाल दोगे केरोसिन विल फ्लोट. ठीक है, केरोसिन विल फ्लोट. But speed of light in kerosene is less than the speed in water. So kerosene का optical density water से ज्यादा है. बात समझ में आई? Yes, oil में भी जिसमें light की speed water से कम है उस केस में oil का optical density water से ज्यादा होगी. And oil still may be float. Okay, so it's like that.
Sir,
Understood?
here in the textbook they have given turpentine oil. So for both
Together. Turpentine is oil.
Just so
Turpentine oil.
1.
Yes. Okay, last question. The refractive index of diamond is 2.42. What is the meaning of this statement?
The speed of light is
Huh?
speed of light is least.
Least in diamond, है ना? तो इसका मतलब ये हो गया. देखो, diamond हो गया तुम्हारा V2. ठीक है, this is equal to C by
Time
N21. ये क्या हो जाएगा? C by 2.42. ये हो गया. मतलब speed of light in diamond is 1/2, almost 1/2 से भी थोड़ा ज्यादा कम हो जाएगा as compared to its speed in air. समझ में आया? What is the speed of light in diamond? 1/2. of its speed in air. ये factor आ गया. So refractive index is the factor by which the speed of light reduces in the given medium. Understood? चलो आगे चलें. Now we'll start with refraction of light by spherical lenses. So do not leave this in text questions. These are very important questions to enhance your conceptual understanding and also important from exam point of view. Okay. So let's do this. So what is a lens? So it is a transparent medium bound by two sides such that at least one side is spherical. Okay. So transparent medium, it is a transparent medium bound by two surfaces such that at least one of the surface is spherical. Okay. So then we have these are the two types of lenses. So just like how these spherical mirrors were made, this is also cut from a sphere, but now solid sphere. Okay. So obviously you may have one sphere like this, and you may have another sphere like this. So this is C1, this is C2. In case of lens, we call the center of lens as optical center. We don't call it pole. Okay. And the line passing through the center of curvature and the optical center is principal axis. This is the principal axis now. So this is a repeat of what we already learned in mirror. Just this sphere is solid in this case. Okay. So half the distance is focus. So there are two principal focus, F1 and F2. Okay. In case of mirror, we had just one center of curvature and one focus. Whereas in case of lens, we have two focus and two center of curvature, right? Because they are cut from two spheres. The same like here. Okay, so you'll have C1 and C2. Okay, so here also you have So what is this? What type of lens is this?
Convex.
This is convex, right? And this is convex. So convex is thicker in the middle, thinner at the edges. Whereas concave is thicker at the edges and thinner in the middle. Okay, there's a description. So this is convex and this is concave. Okay. So now we'll discuss the image formation by convex lens for various object position. Now you'll find that the image formation by convex lens is exactly same as the image formation by concave mirrors. Okay. So first, object at infinity. This is the first case. So you will have a convex lens and you will mark 1, 2, 3, 4, 5 points. And do not label it. First complete the ray diagram, then label it. So what do you have now? So when the object is at infinity, what is the nature of incident ray?
Will pass through.
Now for mirror it used to reflect and pass through focus. In this case it will go on the other side. So refracted ray will have to travel on the other side because this is a transparent medium. So it will not be reflected in the same medium. Okay. So now complete. So this is E1, F1, So easy. Write down the image position. At F2. F2 is behind lens, right? Then what is the nature? Highly real and inverted. So highly diminished. So for every object position, you have to write down the image position, nature of image, and its size. Okay, so it matches the same description as that for image formed by concave mirror for object at infinity.
Sir, somebody is there in the waiting room.
Who is that? Just accept. Let it be. Say. Just click on the board. Okay. Now let's look at. Let's come now. Argue this object beyond C1. Now we will draw the ray diagram for object beyond C1. So recall what was the image position for object beyond C1?
between F2 and C.
Yes, between F and C in that case. So here it should be let us say your object is here. So you have AB. So parallel ray passes through focus. Now here you have to remember, if the ray passes through optical center, okay, it will pass on the other side undeviated because it is coming on the normal, right? So it will pass undeviated. So let us say the ray goes from here. Okay. So this is what will happen. This is F2, C2. So where is the image forming?
Between F2 and C.
Yes. Right. So image between F2 and C2. Real and inverted. Are you drawing the ray diagrams? Ray diagrams. So there we had selected how many rays for here? Any two rays from the four, right? So here what are the possible rays? Parallel to principal axis, ray passing through optical center, and ray passing through focus. If any ray is incident along focus, after hitting the lens, on the other side it becomes parallel. Okay, from these three, any two rays you will choose. Ray passing through optical center will go straight. So my ray looks little curved down, but it should be straight. So is it matching the same nature as that for concave mirror?
You can position between F2 and C2 behind the.
Not behind the lens. F2, C2 I have labeled in the diagram, right? It is behind the lens.
It is not needed.
No, if you have shown what is F2, C2, and you are writing F2, C2, you have shown in the diagram, where is F2, C2? Or if you are not writing, if you are writing just F and C, then you may have. Since you have differentiated F1, C1 and F2, C2, then no need. Is it in the book they are writing behind the lens? It's not required. If you divide F1, F2, then not required. Okay. So I hope no difficulty understanding this. Very similar to image formation by mirror. Next. Okay. Next is third. Object. Bit at C1. क्या हो गया? Object at C1 कहाँ पे बनना चाहिए? C2 at C नहीं C2 बोलो क्योंकि दूसरे साइड क्या हो गया तुम्हारा? ठीक है, तो अभी तुम्हारा ये ऑब्जेक्ट हो गया ए बी C1. ठीक है, so image at G2. Then what do you have? Real and inverted. Same size as object. ठीक है, so now struggle. Can I erase the right side? Yes. What is the next object position?
Between C and
Between C2 and up.
So what should be the nature of image?
Real and
Real inverted, magnified.
obviously.
Obviously, the image size is increasing now. This is same size. Okay, 4. 4 यहाँ पे कर लें. Object between C1 and F1. Object between C1 and F1. So the image should be beyond C2 now. Correct? The image is going away from focus and size is increasing. Yes.
मतलब इसमें ऐसा image lens के पास जाए और object lens के पास और image दूर जाए ऐसा है.
हाँ, मिरर में भी वही होगा.
मेरा तो उल्टा होता है.
क्या उल्टा?
image के पास है object के पास है image दूर है.
हाँ, और इसमें
image के पास है और ये दूर है.
क्या होगा? ऑब्जेक्ट पास आ रहा और इमेज दूर जा रहा है. मिरर में भी तो वही हो रहा था. खाली मिरर में फ्रंट में हो रहा था और इसमें बिहाइंड से. सेम है, सेम पैटर्न है, लेकिन लेंस चेंज हो गया. उसमें कॉन्केव में हो रहा था, उसमें कॉन्वेक्स में. बस पैटर्न सेम है. Okay, try to draw the ray diagrams yourself and see. It is very predictable now. The image is beyond C2. Become image is beyond C2. What's the discussion at the back? About? Discussion about? I'm asking what is the discussion about? Answer. Continuous chat going on. Image beyond C2. What is the nature?
Magnified.
Real and inverted. Nature is real and inverted. Size is magnified. Highly magnified. Only magnified.
Yes, yes.
You can see the object and the image size are comparable. So it is magnified. Magnified. Or you can say enlarged. Highly word add करोगे कहाँ पे? Infinity पे. जब वो object is at
F1.
focus. F1. Fifth. Object at F1. Again, so in this case, image will form at infinity. यहाँ पे highly magnified. Okay. So we have image as real and inverted for 5 position. Now the last one will be virtual image. And now the image will be on the same side as object. Object between F1 and small. Object between F1 and small.
Sir, enlarged and magnified are the same.
Huh?
Enlarged and magnified is the
Yes,
same.
yes. Now see the light, after refraction, the refracted rays are diverged. They are going away. So what do you have to do? You have to extend them backwards. When they are extended backwards, they are matching. So this AB, D dash. What kind of image is this now? Has to be virtual, right? So image on the same side as object. Image on the same side as object.
But here you lose inside.
Huh? I have to write same as object.
But
Because you don't know exactly where it is or perpendicular, where it is inside. Yeah. Now, and second, virtual and upright. What about the size?
relax, man.
Okay, so here you have to, whatever I said, the same side as
Beyond a
beyond F1, you can say, beyond F1, that also is okay. Because F1 is on the. How can you be sure? It can be, but not always.
प्रिया किधर है? ओए ओए माउली, प्रिया किधर है? प्रिया किधर है? मुक्का